Problem 3. We are given two equations that are said to be true, and they're coming in one system of equations. So we're trying to find the value of x. Well, when we see there's lots of denominators and multiple variables like this, we're going to try to make it as simple as possible. So whenever I see a huge expression being repeated multiple times, or maybe not just a huge one, but just an expression that's being repeated multiple times, as in 2 minus x or y minus 3, I usually like to substitute them with a variable, with one variable that just represents that entire expression. So here, what is one expression that we see coming up again and again? You might say 2 minus x, but there's actually a bigger one. It's part of the bigger expression 1 over 2 minus x, since we notice that it's always appearing on the denominator. So we can set this entire fraction as one variable. Let's call this a. Now we can call 1 over y minus 3 as b. Now that we have both of these established, we could replace them into the expressions and it would be much more simpler to solve. So the first equation becomes 3a plus 2b is equal to 1. On the bottom we have 2a plus 8b is equal to 2. Here it definitely looks much simpler and much more friendly to solve. So how can we do this? Well, let's first try by adding both of these equations. Sometimes we just have to play around with the equations until we find something that we can really use to eliminate one variable. So we know that by adding them, we have 5a plus 10b is equal to 3. We can also subtract 1 from 2. This gives us 6b minus a is equal to 1. Well, now that we have two more equations, how can we combine them to start isolating variables? Well, here we have a negative a and here we have 2a. So in order to get just 1a, we'll have to add both of these equations. Then we'll get a plus 14b is equal to 3. But here is when we see equivalent relationships. This expression is equal to 3, and at the same time, this expression is also equal to 3. So by substituting this expression in, we have 5a plus 10b. Now we can start combining like terms. So by subtracting 10b from both sides, we have 10b on the left side, and on the right side we have, on the left side we have 4b, and on the right side we have 4a. Wait, so that means that a is equal to b, which means that they're actually the same variable, they have the same value, and we could interchange them throughout these equations. They're really the same variable. So now that we have that in, let's find out their actual values. Let's take the first equation, for example. Let's decide to use a. So this will become 3a plus 2a is equal to 1. So a is equal to 1/5. Now let's look at what we're trying to find. We're trying to find the value of x, and a actually represents an expression that contains x in it. So we take that expression back. So now we have 1 over 2 minus x is equal to 1/5. This tells us that 2 minus x is equal to 5. So therefore, x is equal to negative 3. So the final value of x would be x is equal to negative 3. In this problem, we solved systems of equations using the solution of replacing large expressions with single variables for an easier solution. Thank you so much for watching Inquisitive Kids. We'll see you in our next video.